Hello everyone, welcome back to Tutors, and today I'm going to be going over an IB example of a problem involving matrices and intersection of three planes. So in this problem, there are going to be variables in the matrix, as we can see here. This is the problem. It gives us a system of equations, and it's known to have more than one solution. And in the context of intersection of three planes, that can only mean one thing. They intersect in a line, and therefore must have infinite numbers of solutions. And in that case, our strategy for going about this question is going to be making the last row all equal 0, so we can solve for A and B, because that's needed for the system to show that there are infinite numbers of solutions. Alright, so in this step, we just put all our numbers into a matrix, and you can see they're just, once again, the coefficients of our x, y, and z terms, and our constant on the right side. So in the next step, as we remember, we have to use row 1 to turn these into zeros. And now the reason you don't need to turn row 1, make the first coefficient in row 1 equal 1 is because you can make it such that it will still equal 0 in the second and third rows by multiplying the first row by something different. So if you take -3 of the first coefficient, add it with 2 of the second coefficient, so -3 times 2 plus 2 times +3, that's going to give you 0. And the same idea for the second. And of course, you must do the operation to the variables as well, because we're doing r1 plus 2 times r2, so you multiply this by 2, so it becomes 2a, 2b, and then you're adding 2 times, 1 times of row 1, so you add 3 to this, and you add 2 to this. And then in the next step, we want to make it so it's easy to turn this into a 0. The first row doesn't necessarily matter because we're not really looking to do anything with that first row. So you just want to focus on this third row. So what we did, we divided the second row by 5 because we can tell 5, -5, and -10 can all be divisible by 5 to simplify it to 1, -1, and -2. So now it makes it easy to turn this into a 0. So what we did is we multiplied this by -3 and added it to row 3. So -3 multiplied by this, adding it to this. So this became 0, which is what we were trying to do. And then -3 times -1 is 3. So you add 3 to this, it becomes 2a plus 6. Same idea here. And then now we have zeros in the rest of the third row, so now we can just set 2a plus 6 equal to 0 and 2b plus 8 equal to 0, because we need these coefficients to equal 0 if the system is going to intersect in a line, which is what we determined at the beginning of the question. That's the only way the system can have more than one solution in the context of intersection of three planes. So therefore, 2a plus 6 equals 0. We solve for a is -3, and we solve for b, which is -4. So I hope that was helpful to you guys, and if you liked it, please remember to subscribe for more educational videos coming your way soon. Thanks.